This is Max Gravit at GG Rocket. The purpose of this video is to describe some of the scaling challenges that we've had with the EOS blockchain and how we address those scaling challenges. GG Rocket is a FAT protocol and dApp meant to facilitate the massive gaming asset economy, gaming data and asset economy. So there are existing bots and protocols that we have that work with the majority of the AAA games. They analyze gaming profiles, detect history of purchases, existing gaming item inventory, any account upgrades that the gamers purchased, other gaming subscriptions, really everything within these games that have been purchased by the gamer. And we use that information to drive the overall gaming economy. We allow the users, the gamers, to sell in-game assets, buy in-game assets, trade those assets. There's a services marketplace. There's also a marketplace where players can sell their profile information, their contact information to advertisers, in which case they're directly rewarded with tokens for those profiles. They can then in turn use those same tokens to buy additional gaming assets. And really facilitates the on-chain economy surrounding AAA games. All right, so this is the typical way that EOS actions will operate. There's a dApp, of course, that's submitting transactions to the blockchain. Then within the blockchain application, or within the blockchain action, the smart contract is going to be performing all of the business logic, state changes, saving data to the blockchain, and all of these things use resources. Key resources, the three resources being used are RAM, CPU, and network, all of which have a different price per millisecond, per kilobyte inside of the EOS system. And again, all of this is happening inside the smart contract. So this is what creates the challenge for GG Rocket, is that we have a very data-heavy problem that we're working to solve, a very data-heavy economy, and we need all of these things to be validated on-chain. These are true assets that are owned by the gamers, so we need to make sure that that information is validated and immutable with all the benefits of blockchain. Yet we have the issue of it can become astronomical to be able to store all of this data on chain. So to address this, we're going to use this methodology called blockchain scarring. And where the word scarring comes from, it's if you're harmed, you have a wound, and that leaves a mark, so to speak. And so what we're going to do is leave a mark on the blockchain from within a transaction, but we're not going to save any data on chain. We're not actually going to be performing any business logic on chain associated with these, with saving of the items. We're just going to be scarring the chain, which is going to give us the benefits of security and immutability, without all of the cost associated with saving data on chain. So here's how it works. The dApp will call into a transaction on the blockchain, and that will log that event occurred. So something happened on chain and it used CPU and network. That's what the C and the N are. It's using CPU and network, just a very negligible amount, just enough to transfer the parameters of that action, and enough CPU, just the base CPU amount needed for a transaction. And we're going to use this new technology that came out just a few weeks ago by the guys that have brought us EOS Canada. They've created this technology called dfuse, D-F-U-S-E. I think it's somewhat similar to dmux. Personally, I haven't used dmux. But dfuse uses a WebSocket, which is just, at least in my experience, has proved to be a great solution to this problem. Then we can perform other business logic off-chain, and if we need to, we can then come back and scar the chain with those event results. So here's just a little more detail of how that plays out in the ggRocket solution. So we're going to scar the chain. The ggRobot bot is going to gather the data feeds from the games. Again, as I mentioned, all the items that they own, everything that they purchased, all the detail about that gamer. Then we're going to scar the blockchain with that information, such as player X has item Y at this current time. And that's going to use CPU and network, but no RAM. We're not going to actually save that information on chain. We're going to use our listener, our dfuse listener, to save that item to the player's inventory off chain. But we know that it actually happened at that moment because we have the on-chain validation of their account was the one that signed the transaction. And of course it's immutable because it's going to be on chain. Then later, when that inventory item is sold, we'll again scar the blockchain with that new event. So that would create a sister scar, if you will, over here that says player Z purchased item Y from player X. And again, that would create the immutability that we would need. So let me give you just a quick demo of how this works. Let's see. I'm just going to emulate the ggRobot part that is simulating bringing in all of the data about the games. We're going to transmit it to the Kylin EOS testnet, and then we're going to have a listener that is pumping that information into a database. Okay, so let's see. First thing I'm going to do is start up the EOS listener. And this just gives you the configuration. Again, it's using dfuse with these various parameters, the contract that I want to listen to, the action that I want to listen for. And now I also have a handler. So the handler is going to process the information that is picked up by the listener. The listener is essentially going to forward the data packet over to the handler. And in our case, our handler is going to be writing it to a database. And then here I have a script that essentially is just going to simulate what ggRobot's going to do by writing a bunch of transactions, in our nomenclature, scarring the blockchain with the information. So let me just check to make sure I don't have any. Okay, so I have this purchases table out in Mongo, and it's currently empty. So let's create some items and see what happens. All right, so that script is just going to create, I think, about 20 items, just based off of some random data that we have. Again, it's creating it on the global Kylin testnet. This is the listener over here on the right. This is picking up all the events that occur as they occur in real time. And it's forwarding all of that data over to our MongoDB handler. And that's what's saving it into our Mongo database that's out in the cloud. And again, this was just the simulator. The bottom left was just the simulator. All right, now let's go back to MongoDB. And here we go. We have our all of our records. So again, these are just records that's saying that this gamer purchased a certain item on a certain source for a certain price at a certain time. Okay, so let's go back here. What does that get us? So we were building a solution to scale in the next couple of months. We're going to be scaling to 350 new users per day, 100 transactions, For each one of those users, they'll have the opportunity to upload all of their profile information, all of their existing inventory, and other information about themselves, about their gaming users, as well as their identity if they wish. And that's going to be at 100 transactions per user. So that gets us to essentially 35,000 transactions, or what we call economic items, per day. And so based off of the scarring that I just showed you, the amount of stake that we would need in EOS to cover our CPU and network is about $3,000. Actually, it's much lower than $3,000. I put it in as $3,000 just to make sure that the video is a little bit future-proofed, just to cover if things do change or if the EOS token goes up. I'm just being conservative there on that amount. And of course, there's no RAM is required. There will be RAM required in the overall solution, but in terms of maintaining accurate records of what every user owns, we don't need any RAM for that because we're not going to be storing that information on chain. So this is a great solution to allow us to really maintain the economy on chain using all the benefits of blockchain without the incredible cost of having to store all the information on chain.